Hello everyone, so in this video, let us talk about another problem from LeetCode. The problem name is find minimum in rotated sorted array. Okay, so if you haven't checked out my video on this problem, that is finding out the peak element. First, please go and check out that particular video. It is very helpful and it will make you understand this problem very easily. It is in the binary search playlist, so go check it out and try to watch the complete playlist. It will be very helpful. Now, coming down to this problem, it is somewhat related to it, but it requires a little much different logic. Okay. The overall structure remains same, but some different critical thing is required. Okay, let's not move down to the problem statement first. It says that you're given an array of length n sorted in an ascending order and is rotated 0, 1 or n times. Okay, so it is rotated as well. Like initially it was sorted and then it was rotated. I'll tell you with some examples as well. Now, what rotated means, I'll also show you with some example as well. But you have to find out in that sorted nums array, find out it has all the unique elements that is also given to you. You have to find out the minimum element inside the array, and you have to write down an algorithm that will find out and run it in log n. Whenever I've told you in the previous example as well that whenever I see log n, I generally try to think over in binary search direction because over an array, if you find out if you have to search something in log n time, it's better use a binary search. Like there can be multiple things, but it's better to think in that particular direction first, at least. Okay. Now, let's take some example, understand the problem statement, and then we'll try to find out some solution. So let's take this as example. So the only thing is that we are given some array. There is, let's say, let's take some example. There is, let's say, sorted. It has unique elements. So 1, 2, 3, 4, 5. Okay. Now, if I rotate it, like put this element to the very back. Put this element in the very back of the array. So it will become like this: 2, 3, 4, 5, and 1. Now, if I rotate it one more time, it will become 3, 4, 5, 1, and 2. And this is the example that is given to you here. So it is an array that is rotated 2 times. Okay, that is given to you. Now, you just have to find out the minimum element of this array. If it is a binary search, simple binary search problem, then you could have done it in just log n time because you can do binary search in log n time over a sorted array, but it is rotated sorted. So like sorted and then rotated. So how can you do that? Because you cannot directly use binary search here. You have to do some technique here. So binary search, as I've told you, always try to converge to a particular point. So what you can do here is let's try to draw. Always try to draw binary search and try to find out what is the local minimum maximum that you have to find out here. So what you can see here that let's draw it out. Let's say if the first element is 1, the next 2, 3, 4, 5, 6. So it is like increasing like this. Okay, like a complete increasing. But if in the problem that we are given to you, that is like this array, what is it's like this? Let's say, okay, let's draw it like this. Let's say this is 3, this is 2, this is 1. So it is increasing from 3, 4, 5, and then there's a drop to 1. And then it is increasing to, let's say, that's the graph you can see here. So what you can see is that there's a graph, there's a minima. Like you can say that there's a point. You are on this side or this side. Okay, there's a point that you have to find out. This is the minimum point that you have to find out. This is the one. Okay, you can easily spot out some points that you have to actually find out in binary search problems that you can use here. So we can understand that, okay, we can try to use binary search here. Now, how can we find out this particular point? Because both the sides are increasing. If you have seen the previous problem, that is the peak element is such that it is increasing on one side and then decreasing. So you can easily find out that whether I am on the left side of the hill or the right hand side, and we can go to the local maximum minima that you have to find out. But here, both of the sides are increasing. Like this is 3, 4, 5, this is 1, 2, or like 1, 2, whatever you want. So both of the sides are increasing. We cannot understand that which side I'm on. I am like whether I'm going towards the local minima or I'm going away from it. Okay. So how can you do that? That's the like little bit critical thing that you have to do. But if I use binary search here, what you have to understand here is that instead of comparing it to the neighbors, in the previous problem, we are comparing it to the neighbors. But now we can see that if it is increasing, like it has sorted, it is increasing here, the elements on this side, because it is here, it should be, you can see it is down. It is like below this line. Why I've drawn it here, why I've drawn this line, it makes you understand that if I'm on this side, which is like increasing like here, minimum, it should be smaller than this extremity, like the element that is in the very front. Why? Because the element in the very front should be like, it is a sorted array now, so it is like rotated. So it has to be having some element. Then it will increase. Then it will decrease to a particular minima point, and then it will always increase to till this point. You can say. Okay. So what you can see here is that all the elements on this side, like this side, should be less than 3. And all the elements on this side should be larger than 3. And that's it. That you can do here to find out which side you are on and which side you have to go. Because in binary search, you first go to the middle, and then you have to understand whether I have to go to the right and left. Like which side is the actual minima or maxima that is actually lying. So if I somehow lie this, we just have to take this element and compare it with the first element. And that will actually help me understand that I am going close to the minima, or I'm actually have to go on the right hand side or left hand side to find out the minima. And that's the complete logic that you have to find out, that instead of comparing it with the neighbors, generally you compare it with the neighbors to find out like minima, maxima. In this, you have to compare it with the very extremity, and using that and find out that whether I have to go to the left hand side or the right hand side. That's it. That's the complete logic that you have to use. Let's move on to the code part now. If you still have any doubts, you can mention in the comment box. We have find out that the extremity is LNR of the, you can say, binary search. Very simple standard thing. Do it completely till L is less than R. Find out the middle element. Now we have to understand that if I have reached the, you can say, point, the minimum element, how can you do that? That I am on the minimum element. The minimum element is such that, so as you can see, all the elements to the right of it, for every element to the right of it, it is smaller. But for the minima element, the right of it should be larger. So for if I'm on this, the previous element, always the previous element, because it is increasing, the previous element should be smaller because it's increasing. But if the previous element to any element is larger, then which means that this is the minimum element. So that's what we're checking. The previous element, mid minus 1, exists. And if it is smaller, mid minus 1 is smaller. So as you can see that like so mid minus 1, as you can see, the nums I am on mid. Yeah, it's so as you can see, sorry. If this is larger, sorry. If the element I am on is larger, the mid minus 1 is larger, sorry. If mid minus 1 is larger than the current element, then we are on the mid element. That is fine. That we're looking for. If not, then we either have to go to right or left, depending upon that if the element I am on, as you can see, if it is larger, then the extremity, then which means that I am on this side. And if I'm on this side, I have to go to the right hand side. And if I go to right hand side, I have to make my L equal to mid plus 1. If I go to the right hand, you can say left hand side, I have to make my R equal to mid. Pretty much simple. That's a very standard, and I have to use the same technique of binary search in the previous problems and all the rest problems, that you have to make L equal to mid plus 1 and R equal to mid. And you will keep on doing this while loop until you find out the answer. And we'll always find out the answer because there always exists, because it is saying that it is a rotated sorted array. So they will always return a minimum answer, and we will always get answer from there. That's a complete logical code part for this particular problem. If you still have any doubts, you can mention it in the comment box for this particular video. I will see you in the next one. Thank you, coding and bye.